Next question, 2.4. Now this one, it would require you to know your laws of exponents, because you can see over here I have exponents, but this one is a little bit different than the one we did earlier in that we are adding here instead of multiplying. But this shouldn't be a problem. We should be able to do this one. Now here I see I have an exponent that is a sum, and what I do is I need to know how to use my laws both ways. How if I have two terms multiplying where the bases are the same, I add my exponents, and here the exponents are already added. I should know I probably have to rewrite it so that my bases are multiplying. So let's do that. So this is 2 to the power of x, and I'm multiplying because my bases are adding, so I don't say plus over here. It is 2 to the power of 3. So I can always work backwards. If I have 2 to the power of x times 2 to the power of 3, bases are the same, I'm multiplying, I add them together, I would have x plus 3. Okay, I do the same thing with all the terms. So this is 2 to the power of x times 2 to the power of minus 1. Here I say times because x plus minus 1 is just x minus 1. So I haven't changed anything. I just want to rewrite them in terms of multiplication instead of division. You can still try it in terms of division. Your answers will be exactly the same if you do it correctly. And then the last term, I have 2 to the power of x times 2 to the power of minus 2. And then this one over here, 70. This is just 70. For now, I'll leave it like that. Okay, so I look on my left hand side, I notice something. This 2 to the power of x is a factor there. It is also a factor over there, and it is also a factor over there. So when you see a common factor and you're maybe not sure what to do, it might be helpful to factorize. So I have a common factor. Why don't I factorize? So I'll factorize out 2 to the power of x. What do I have left? 2 to the power of 3. And then plus, because this is a plus over there, what do I have left from that term? I have 2 to the power of minus 1. And then the third term, if I remove 2 to the power of x, what do I have left? 2 to the power of minus 2. And then this is equal to 70. Now these values here, 2 to the power of 3, 2 to the power of minus 1, 2 to the power of minus 2, those are all just numbers. They're like terms, and I can add them together. So what I do is I will evaluate or work out what these values are, add them together, and then see what to do from there. So here is my common factor, 2 to the power of x. Now I say 2 to the power of 3. What is 2 to the power of 3? It's 2 times 2 times 2, which is 8. And then this one here, 2 to the power of minus 1, this is 1 over 2. So this is half. And then this one over here, 2 to the power of minus 2, this is just 1 over 2 to the power of 2, or 1 over 2 squared, which is 1 over 4. And this is equal to 70. Now I can see them clearly that these are numbers that I can add together. So 2 to the power of x, and here I have 8 plus half plus 1/4. If you don't know how to do it, take your calculator. This question doesn't restrict us. It doesn't say do not do it without a calculator. So I'll do it. I have 8 plus half plus 1/4. What do I have? I have 35 over 4, and that's what I will write here. 35 over 4, and this should be equal to 70. Okay, now that I have that, remember how we always solve these questions. We always say everything with x on one side, everything that doesn't have x, go to the other side. So I can see these two are multiplying, so to get rid of this one, I should divide. So I have 2 to the power of x, and then I've divided, so I have 70 divided by 35 over 4. So I've divided by 35 over 4 on both sides, and when I did that, it cancelled out. Now you know how to divide fractions. When we're dividing, it changes to multiplication, and then I write the reciprocal of that one. So I should have 2 to the power of x. This is equal to 70. The first fraction stays as it is. 70 is just 70 over 1. I want it to look like a fraction. The division, we say, changes to multiplication, and then the reciprocal of this one, this is 4 over 35. Okay, so I know 35 goes there once, it goes there twice, and my answer is 8. Or we could do it on a calculator if you like, just to check. I have 70 divided by, I'll just work it out from here. So I have 70 divided by 35 over 4. What is this equal to? It's 8, so we're correct. Okay, so what do I have left from here? I have 2 to the power of x is equal to 8. Now this one here, what you can do, you can take logarithms on both sides, that is also fine, but this 8, I think by now you should know you can rewrite 8 as 2 to the power of something. So I have 2 to the power of x, this is 2 to the power of 3, because 2 times 2 times 2 is equal to 8, so 2 to the power of 3 is equal to 8. Then here, it's just a matter of comparison. You look at your left hand side and your right hand side. The bases are exactly the same, so it means my exponents must also be equal. From here I can conclude that x is equal to 3.